So hi friends, good morning. So this is Reshma. Welcomes you to the session on database management system. And in today's session, I'm going to discuss with you a very important and basic concept of relational algebra. So that is the join operation. So now this join operation, the concept of join operation will be same in relational algebra and also in SQL. So if you become perfect in join operation now, so when we will go for SQL, so we will find very easy to solve the queries using structured query language. So now see what is join operation here. So now this join operation is used to combine the related tuples from two relations and we'll get one single relation with longer tuple. So join operation is used to combine related tuples from two relations and in the result we'll get a single relation with longer tuples. And with the help of this join operation, as the name indicates, it allows us to process relationship among the relations, that is joining the relations, and it is denoted by a general symbol which is given here, in pink color. This is the join operator. So now here the general form of join operation and two relations can be defined like, assume that I have two relations here, relation R and S. Relation R contains attributes like A1, A2, etc. up to AN, and relation S has B1, B2 up to Bm, and it is denoted by the relation R, then joining operator, next join condition, then the second relation, that is here we are joining relation R with relation S with some join condition. So this is the general representation of joining of two relations. And once we get the result so of the relation of the joining of these two relations, the result of the relation contains n plus m attributes. Okay, the result of join contains n plus m attributes, that is all attributes of the relation R plus all attributes of relation m will be available in the result of the join, and it is denoted like resultant relation is Q, which contains all attributes from the first relation followed by the attributes from the second relation. This is the order of the attributes in the resultant relation. So then a concept of join selectivity. So the join selectivity is the property of each join condition. So whenever you are applying the join condition, each join condition will have a property referred to as a join selectivity. So means here, if the relation R has nr tuples and relation S has ns tuples, then the result of the join operation, or join condition is, so the result may contains either 0 tuples or nr into ns tuples. Okay, so the result of the joining operation, it may contains a single tuple or nr into ns tuples. Okay, so this is about the join selectivity and the number of tuples in the result. So that is, the result contains either 0 or nr into ns tuples based on the selection condition based on the join condition. So the expected size of the result, join result, divided by maximum size, that is NR into NS. This gives us the join selectivity. So join selectivity is the ratio between expected size of join result divided by cross product of NR into NS. For example, if that relation R contains 5 tuples and the relation S contains 10 tuples, and assume that the result of the join operation, the expected size may be 6 tuples. So then join selectivity will be equal to expected size 6 divided by cross product of number of tuples in R, that is 5, into number of tuples in S, that is 10. So it becomes 5 into 10, 50. So here the joint selectivity will be equal to 6 divided by 50. So now here, whenever we are performing some join operation, as we have seen in joint selectivity, denominator is cross product. Then what is the relationship between this join and the cross product? So now here, the join operation, it can be related with cross product, like the join is same as cross product followed by selection operation. First we need to multiply the two relations, then give some selection condition. So this combination of cross product as selection condition gives us join operation. And we know why so again here, when we should go for cross product, why we need to go for the join. So now we know in a relational database, it is a collection of relations. So now whenever we need some data, whenever we want to retrieve some data from the database, if the required data is available in single relation, then we can extract the data directly from that particular relation. For example, if I want to know in company database, if I want to know employee name and employee salary, which is available in employee table itself, then that table directly I can retrieve. But if I want to know the manager of the employee, then the manager of the employee available in department table, employee details available in employee table. So name of the employee in employee table, manager details in department table. So now in such cases, it is not possible to retrieve the data from single table. So there I have to go for the join operation. So now before applying join operation, first I need to perform Cartesian product of each tuple of employee table with all tuples of department table. So there I will get NR into NS tuples. Product of tuples will be the result. So from those tuples, we need to select only those tuples where employee is having some manager. So in such cases, we need to go for joining. So that is, joining will be applied if we need the data from the database which is not possible to extract from the single table. If it is related, the data which we are going to retrieve is a related data between 1, 2 or any number of tuples, more than one relation. If you are trying to retrieve the data, then we need to go for join operation. So which is the selection condition on Cartesian product. That is, we can write Jan as join is equal to Cartesian product, that is cross product plus selection condition. Then what are the different ways to join two tables? So join can be done in different ways. So here just one example I have. See here, in the first relational algebra expression, I have first cross product, then selection. So now this cross product and selection, there are here two expressions. Now these two expressions can be combined and it can be replaced with a single operation. See here in the second expression I have given join. So that is cross product and selection condition can be replaced by a single join operation. So then based on the type of data we are extracting, based on that we need to apply different types of joins. Different types of joins can be done. So what are the different type of joins which we can apply on any relation? So mainly here we have two categories, inner join and outer join. So what is inner join? So now here inner join means, assume that we are applying, I want to join relation R and S, and in the result I need only those tuples which satisfy the condition, which satisfy the join condition. That is, I want to select only those tuples which are having matching tuples. Okay, so in inner join operation, for example joining of R and S, only tuples from R that have matching tuples in S, or tuples in S which are having matching tuples in R. Matching tuples in both R and S should be retrieved. In such cases we need to go for inner join. So now here what about the tuples which are not matching? So that is in inner join, the tuples without match, the tuples which are not related between those two relations, they are eliminated from the join result. Here the purpose of joining two relations is to extract only those tuples which are matching between those two relations. Other tuples should be eliminated. So sometimes the relation may have null values. So then how it will treat those null values, whether they will come under matching tuples or not matching tuples. So here null values will come under not matching tuples and they should be eliminated. So this is a special type of, that is, this is the inner join where you should remember no match are eliminated. Only matching tuples are eliminated. Okay. If there are no matching tuples, they should be eliminated. This is the concept of inner join. So now here again, here we said matching tuples. In what sense we are matching? So what are the different comparisons operators we need to use? Which are the different attributes we need to match? So what is the basic criteria for matching or joining the relations using inner join? So based on that, we have categorized inner join into equijoin, natural join, and theta join. So this is the first type of the join where we have three categories. The next type of join is outer join. So then what is outer join? So what is the difference between inner join and outer join? So that is, in outer join operation on, so two relation R and S. So here result will keeps all the tuples in the left relation R, then all the tuples from right relation R, S, and sometimes all the tuples which are available in both the relations will be displayed in the result of outer join. So here, why it is displaying the tuples from both the relations sometimes? So because here outer join is not eliminating the unmatching tuples. So that is, regardless of whether the tuples are matching or whether they are not matching, so then also it will keep all the tuples. So this is the concept of outer join. So that is, outer join, it will keep all the tuples regardless of whether or not they have matching tuples in other relation. When I am applying two relation R and S with outer join operation, result will contain tuples from relation R, from relation S, or from both, regardless of whether they are having matching tuples or not. So this is outer join. Then again here I said it may keep tuples from left or relation R or from relation S or from both based on which relation tuples you want to keep in the result, whether you want to keep the all tuples of left relation or from right relation or from both the relations. Based on that, outer join will be categorized two into three different cases, because it will keep both matching and not matching tuples. So here we have outer join, like left outer join, the symbol is this. Right outer join pointing towards the right table. Full outer join pointing towards both left and right. So that is left outer join, it will keep all the tuples from left relation. Right outer join all the tuples from right relation. Full outer join, it will keep all the tuples from both left and right. So when it is keeping only left, all tuples of left relation, what about the right relation? So it will pad unmatching tuples with null. Matching tuples will be displayed from both the relation. In left outer join, left relation tuples will be kept. In right relation, unmatching tuples will be padded with null. So if I go for right outer join, again all tuples from right relation will be kept in the result. So from those, some may be matching, some may not be matching with the left. Matching tuples of the left relation will be kept and unmatching tuples padded with null. Similarly, in full outer join, tuples from both left and right relations will be displayed. Again, for matching, we'll keep those tuple values. For unmatching, we have to keep a pad with null values in corresponding relation. So this is about the basic of join operation. So remember, join operation will be used when we need to extract the data from the database, which is not possible to extract, which is not available only in one relation. As the relational database contains related data, it may be scattered in different tables. With a single expression, we can extract the data available in multiple tables at a time. That will be possible with our join operation. Okay, thank you for watching the video. If you have any questions in join operations, please post your questions in the comment box. And from my next session, we'll go in detail about each inner join operation. To get the notifications, please subscribe to my channel and click on the bell button. Thank you.